Okay, second review over the unit test. You need to simplify this expression. So we have 12 times x to the second power times y to the negative second power, and then a second power outside the quantity, 4 times x times y, negative third, negative third. So it's all multiplication. So we look at what we have, we lay the problem out like that. So we have a 12 times an x times a y times a 4. Another x means I add to the first x I have. Another y means I add to the y I have there. So, and everything starts on top because there's no division line. So that means I will be moving some things to the bottom if I need to. So 12 to the 1. So I take 1 times 2, that's 2. Then there's 2 x's, so the first x is to the second. 2 times 2 is 4. And the other x is to the first, so I take 1 times negative 3, and that's negative 3. So 4 plus negative 3 is 1. Okay. Now y, there's 2 y's here and here, so the first y we have to multiply negative 2 by 2, that's negative 4. And the second y we have to take negative 3 times negative 3, which is 9. So negative 4 plus 9 is 5. On the 4 we take 1. 1 times negative 3 is negative 3. So we do the switch stay. So 12 to the second power stays because it's positive. X to the first power stays because it's positive. Y to the fifth, that's going to stay. It's positive. But the 4 to the negative third, okay, that's a negative, so that's a switch. Okay. So we switch the 4 to the bottom and then make negative 3 turns into 3. Now on top, 12 to the second, that's 12 times 12, and that is 144. Okay, we also have the x to the first. If the variable's to the first power, you can just put x, then y to the fifth. Okay, now on bottom we have 4 to the third, that's 4 times 4 times 4, and that equals 64. Now, remember to put 64 on the bottom because that's where 4 to the third was at. So if you divide 144 by 64, you get a decimal, so I'm just going to leave it. Okay, number 2, w to the second, then on bottom w to the fifth times w to the sixth. So on top I have a base of w, on bottom I have a base of w and a base of w again, so that's a plus. So the w on top's to the second, and then on bottom we have 5 plus 6. 5 plus 6 makes 11. Now, you're going to cross out that w from the bottom. You cancel it, you subtract 11, and 2 minus 11 is negative 9. So that's a switch. Okay, so that means w needs to go to the bottom so that the negative can be dropped from the exponent 9. And then we cover the top with a 1. So that's pretty much the answer. 1 over w to the 9th. Okay, next one, if there's 2 separate fractions, you can combine it into 1 on a multiplication problem. So you have 4 times x to the 10th, a second. On bottom you got 5 times x to the 7th, and then a. So on top we have 4 times x. On bottom we have 5 times x times a. So 4 is to the first on top, no parentheses. The x we take 10 times 2, that's 20. Now the 5 on bottom's to the 1, no multiplying because it's not in parentheses. And then the x on bottom's to the 7. And this a is to the first, but since it's inside the quantity, the parentheses, we take 1 times 2, which is 2. Now, I have an x on top and an x on bottom, so we subtract 7 from 20, and I end up with x to the 13th power. So 4 to the first, that's a stay. X to the 13th, that's a stay. On bottom, 5 to the first, that's a stay. So that means it stays on bottom. Then a to the second, that's a stay. It stays right where it's at. Okay, then on top, 4 to the first is 4 times x to the 13th. 5 to the first is 5 times a to the second. Okay. Now, if you want to divide 4 by 5, you can, but it's a decimal, so we need to just leave it as a fraction. Okay, number 5. We have 3 times c to the negative third times e to the sixth to the negative second, then c to the eighth times e to the negative fourth. So my numerator's factors are 3 times c times e, and my denominator factors are c times e. So we can count on crossing some things out, c times e. So 3 is to the first, so we take 1 times negative 2, that's negative 2. Now c, negative 3 times negative 2 is 6. 6 times negative 2 is negative 12. Now bottom, you got the 8th power on the c, no multiplication because it's not inside the parentheses, it's just around the top. Now we subtract 8 from 6 on the c, and that's negative 2. Now we subtract the negative 4 from the e, and that's the same as negative 12 plus 4, which is negative 8. Okay, that's a switch. So move the 3 to the bottom, the negative 2 becomes positive 2. That's a switch. Move it to the c to the bottom, the negative 2 becomes positive 2. And that's a switch right there on the negative 8. So 1 over the top. So we have 1 on top, then 3 to the second, that's 3 times 3, and that's 9. And then my denominator is c to the second times e to the 8th. Okay, scientific notation. We have 4.2 times 10 to the third times 8 times 10 to the ninth. Simplify, write each answer in scientific notation. Now we're going to reorganize the parentheses so that the 4.2 goes with the 8, and then the base 10 to the third goes with the base 10 to the ninth. So 4.2 times 8 gives me 33.6 times 10, and then I add the 3 and the 9. 3 plus 9, that is 12. Okay. Now the decimal has to be in the right place, so I start at the beginning, and the first digit that isn't a 0, the decimal has to be between that and that. So I move it once, so it puts us at 3.36. Then I need to either add or subtract 1 to my exponent, but which is it? That's a 1. Put a 1 next to your 12. Well, you moved it to the left, which is positive, so it'd be 12 plus 1. That's a 1 right there. Okay. So 3.36 times 10 to the 13th power. Okay, now in division, we divide the 2.4 by the 6, which is 0.4. Then you cross out the 10 from the bottom and subtract negative 6 on top. That's the same as 3 plus 6, which is 9. Okay. Now, you start here, 0. This is the first number that's not a 0. So we put a 0 after it, and the decimal has to go between the 4 and the 0. So I move it once, so it's 4.0. It means I need to change my exponent. So I moved it now to the right, so that's minus 1. So it's 4.0 times 10 to the power of 8. Okay, now graphing. 3 times 1/2 to the x power, okay? That's an exponential function, expo. So we're going to create an input-output table. We'll put 0 in the middle and just pick 2 numbers to the right, 1 and 2, 2 inputs to the left, -1, -2. So I'm going to look at this. I know that at the end I'll have to multiply all of my outputs by 3. But for now I need to deal with the 1/2 to the x power. That's your base. Caret, 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 caret. 2, 1, 0, -1, -2. So we do the second power first. So that's 1/2 times 1/2. And that's 1 over 4. 1 times 1 is 1. 2 times 2 is 4. Now, when we do the negative exponent, what that does is reciprocate. It doesn't make it negative, okay? It reciprocates it to 4 over 1, which is 4. 1/2 to the first is 1/2, so the reciprocal is 2 over 1, which is 2. Anything that's 0 power is 1. So now you have 1/4, 1/2, 1, 2, 4. But no, you need to multiply them all by 3. Okay. So if I take 1/4 times 3, that's 3/4. We take 1/2 times 3, it's going to be 1 and 1/2. 1 times 3 is going to be 3, 2 times 3 is 6, 4 times 3 is 12. Okay, I forgot to number this, I'm sorry. Okay, 0. Go 2, 4, 6, 8, 10, and 12. You don't need to do the negatives because all the outputs are positive. I will number the graph for you on these. So -2, 4, x, y. So I would start there because 12 is easier to graph than 3/4. So I go left 2 up to 12. -1, 6, left 1 up 6, 0, 3 right there. Then 1, 1.5's there. And then the last two we know just take us closer to the x-axis. So we go extreme that way. But then what we do here is on the other way, we get infinitely closer to the x-axis without crossing it. Okay, next problem, we have 1/2 times 3 to the x power, another expo function to graph. So again, we use an input-output table, 2 to the right, 2 to the left. So we're going to need to multiply by 1/2 here, but first we have to do 3 to the following powers. So 2 here, 1, 0, -1, -2. So 3 to the second, that's 3 times 3, and that's 9, okay? So then down here is where we're going to get 1/9, because remember the 9 is the same as 9/1, so we flip it to 1/9. 3 to the first is 3, that's the same as 3/1, but then down here we'd flip it to 1/3, and then this is 1. So you have 9, 3, 1, 1/3, 1/9. Now we need to multiply all those by 1/2. So 9 times 1/2 is going to be 4 and 1/2. 3 times 1/2 is going to be 1 and 1/2. 1 times 1/2 is 1/2. 2/3 times 1/2 is going to be 1/6, and 1/3 times 1/2 is 1/18. Now we're going to want to start here now, so we go right 2 and up 4.5. 1, 2, 3, 4, halfway. 1, 1.5, 1, 1, and then halfway. Then 0, half. We're just going by 1, so I don't need to number off, okay? Like I did on the last one. You get closer to the x-axis, arrow, and then that way, okay? Extreme, closer to the x-axis. 3, the base of the exponent 3 is bigger than 1, so that's a growth function. On the back, the 1/2 to the x power 1/2 is bigger, less than 1 whole, so that's called a decay function. On a growth, as x gets higher into the positive, your graph grows. On a decay, if x gets higher into the positive, it decays. It gets extreme on the negative side. So the cubed root is 64, so that means what times what times what is 64? Is it 1? No. 2? No. 3? No. It's 4. Okay, now.
Hey, for Josh, because he's in the choir like every day.
Yeah, he said it was okay, but it can't happen anymore.
No.
Okay,
well, I just figured now I know that cross country's over.
Yeah.
He can come in after school.
He can, absolutely. Thank you
okay?
for telling me. Absolutely. Yeah.
Okay.
Yeah.
Okay,
Thank you.
like,
I told him. I asked him every day, is this a problem? He said no. Okay. So, well, now I know. Thank you.
Yeah.
Yep.
Yeah, sure, no problem.
Yep. Absolutely.
Since cross country's over.
Yeah. 100%. Thank you.
Thanks, Tori.
Yep. Okay, next one. 16 to the 3/4 power. Okay. So what you need to do is take that bottom of the fraction. That's a root. It's a 4th root. You put 16 inside, close it, and take it to the 3rd power. So you got to figure out what the fourth root of 16 is. So what times what times what times what is 16? Is it 1? I don't think so. Okay. It's 2. Okay, so 2. And then it's 2 to the third power. So we have to take 2 times 2 times 2, and that equals 8. Okay. So 16 to 3/4 power equals 8. That's why you handle a fractional exponent, also known as a rational exponent. Make the bottom into a root. Okay. Now we have 2 story problems. A customer deposits $5,000 in a savings account that pays 3.4% interest compounded quarterly. How much will the customer have in the account in 7 years? Quarterly means that n equals 4. So your variables are P, okay, R, N, and then T. You also have A in front, okay? A is what you're finding. A is the new amount of money. New amount of money, okay? P is your beginning amount of money. It's called the principal. Beginning amount of money. And we know that that is 5,000. Okay, now R is your rate, so 3.4%, okay? Okay, but you need to make that a decimal once, twice, okay? So it's 0.034, okay? Not 0.34, that's 34, okay? 0.034. Okay, N is how many times in a year? And we know that N is 4. And T is how many years there are, okay? And there are 7, okay? So again, in that formula, A is the new amount of money, which is what we're finding. P is the beginning amount of money, 5,000. R is your percentage, okay, 3.4%, but you need to move the decimal twice left. But 0.34 is only one time. You need to move it again, so it's 0.034. N's the number of times in a year. Quarterlies are 4. There's 4 times. T is the years. So now you put it in. So the A is what we're trying to find. 5,000. 1 plus the rate, 0.034. And then 4. Then your exponent, N times T, 4 times 7. Okay. Okay, now, a couple things. We put the 500 down in its times, okay? Or 5,000, excuse me. Now you figure out your parentheses. 1 point, and first 4 times 7 we know is 28. Okay. Now figure out just in the parentheses 1 plus 0.034 divided by 4, 1.0085 to the 28th power. Now we just plug it in, straight shot into the calculator. All right. You simplify your parentheses. 4 times 7 is 28. Okay, so $6,337.17. Okay. Okay, number 13. This will be the last problem. Number 14 is not on the test. Get rid of it. Okay. The number of students enrolled at a college is 15,000 students. Enrollment is decreasing by 4% each year. How many students will be enrolled 10 years from now, assuming the trend continues? So the 2 units you have is students in years. So years is X, students is Y. Okay? So per students per year. But there is no students per year. It's a percent per year, which is 4%. It's decreasing, so it's minus 4%. So what we have here between the 2 units is an exponential function. Just put expo, okay? So what you need to find, if you are minusing, that's called a decay factor. If you're adding, it's called a growth factor. If you just want to put factor, that's fine. To find your factor, you take 100%. Minus 4%, which is 96%, and you move the decimal twice to the left, so 0.96. Okay. Now you go to a table. X is years, Y is students. Okay. 0, 1, 2. So 15,000 students times 0.96. You start multiplying. 15,000 times 0.96 is 14,400. Then you multiply by 0.96 again to get the second year, 13,824. And we block it off and we put 10 in for the years, question mark for the students. Now we don't make a line because an exponent function, as we saw in the graphs we made earlier in the packet, does not make a line. It's not a linear function, okay? On an exponent function between two units, you take a times b to the x power equals y. So we know that this is a and this is b. So 15,000 times 0.96, and the 10 replaces the x. And y is what we solve for, so y is all by itself. So you take 15,000 times 0.96 to the power of 10. So we're talking students here, so we probably don't want the decimal, 9,972. The 4 after it would not round up to a digit, okay? And that is your answer.